Alright, if you remember this from a little while back, we modified this mask to where it runs on 9-volt battery, and you can kind of see it. See the mouth is flashing and the eyes. Anyhow, we're going to upgrade it to run on an AC adapter. Reason being is a 9-volt battery is great and all, but let's make it run on AC power. I already took the screws out like last time, but I did not drop or break it this time. So, you see the lights are still here. I'm also going to remove this piece, which is the IR sensor, like I talked about, and put it in his chin. I'm tired of going up to it and pointing the remote as close as I can because the point was to control it from across the room, not from 6 inches from the side of his head. So we're going to cut off this insulation and extend this and try and put it in his chin. So, what you're going to need for this is wire to extend that. Also to connect to a barrel jack. You can use different types of jacks. I'm going to use I believe it's a 5mm barrel jack. And then I'm going to use just an AC adapter I have lying around. This one came apparently from Home Medics. It's a 12-volt adapter at 800 milliamps, which this whole thing only draws 0.2 from the last time on its highest setting. So 800's fine. It's well over what I need. The reason I chose this adapter is so I didn't have to splice the ends because it's designed for that barrel. So just makes life a little easier. You can get adapters like this or jacks online. eBay, Amazon, general electronic stores. There's a whole bunch of different shapes and styles. Find what works for you. So, first things is I'm going to disconnect that so we don't break it. And let's remove this 9-volt battery. Like I mentioned the last time, I had to shave out the battery pack and I didn't show it. This is what I mean by shaving it out. You can see their lines used to be here for the double A's, and the metal plates used to be in here. Those have all been removed and ground out. That way it can fit a 9-volt and still have the cover closed. I was thinking about putting the jack up inside here, and then just either just notching the back a little bit for the wire. That way I don't have a jack in the bottom of his chin. So if I take this top piece off, there's would hopefully be nothing connected to it other than the IR sensor. So the IR sensor I was thinking about either sticking out here or just maybe dropping it out next to the on-off switch. If I want to make it so the face can come off without any problems, I would just bring it out the bottom next to this off-on switch. Maybe have it hang down over here, so it doesn't interfere with the off-on switch. Technically you don't need an off-on switch if you're using a remote wired lighting system, because it has an off-on on it already. So off-on switch is just there to ensure there's no leakage current going through the little microcontroller that would drain the battery faster. So let's get this project started. So since my battery sits in here at an angle, because it doesn't quite fit straight, I can either stick the jack here, the angle's this way, or here. And because this is a straight jack end and it's not a 90 degree, I'm going to stick it here so I can just run the wire down. I'll probably have the wire run either right on this corner or in the center, so I don't have to worry about notching the door where the two tabs are that fit inside. You'll also need a drill, soldering iron. You can use a normal drill bit. I'm going to use a step bit. This is the third step to make it fit in the hole. They're just easier. I don't have to go hunting around for a drill bit that's big. So, if you do use a step bit because they're tapered, if you just come in here like this, you can easily just cut right through your wiring, which would defeat the purpose of the project. So you gotta do it carefully. You can try and mark your spot with a indentation. I'm just gonna freehand it and hope all goes well. There we go. Which is again the third step. You see it's a nice fit. Blow out some of the dust or the drill material. And we're going to spin on the nut. The nut's metal, the threads are plastic, so if you cross thread it, you will damage it. That's what I'm trying to avoid. It got stuck at an angle. There we go. Then I'll use a pair of pliers to snug it up, like so. And just to ensure it doesn't vibrate out, I'm going to put a drop of Gorilla Glue on it. And so if I'm plugging it in or unplugging it, it doesn't vibrate loose. So you can use hot glue as well. Hot glue might work better if you ever have to change the jack. You can just break the hot glue. Whereas Gorilla Glue, Super Glue, acetate glues in general, it's a little harder to do that. So I'm going to let this dry. So while this dries, over here, I'm going to cut off this insulation. And I'm going to turn on the soldering iron. If you're not sure about the controller, you don't have to cut off the whole thing. You can just cut off the end. Meaning, if you don't remember which is positive, which is the far side here, and the voltages, which is 5 to 24 volts. All this black material is just heat shrink. I'm not cutting too deep, so I don't cut through the wires that are under here. As you can see, they're now exposed. And we'll use some scissors. Cut that off. So, the power wires are tucked a little farther underneath. The 3 pins right here, the 3 pins for this. And when you solder, desolder, and resolder, make sure you have the 3 pins in the same spot. Very important. I can use 4-wire and just remove one of the wires, or I can just use some 2-wire and just run 1 wire twice, just making sure I don't mess up the two colors. So since this is up here and I want it to come out down here, I'm going to have to run about 9 inches of wire according to the mat scale. That way it gives me a little play. Alright. So now I got my 3 wires, 2 reds and a blue. Let's get the drill out of the way, make life easier. Couple ways to desolder. One way is you add a little fresh solder to it and then you can remove it easier. You can try and just heat up the solder that's already there and then pull it off. You can also just cut the 3 pins closer to the circuit board and just resolder to them. There's any number of ways you can do it. Just to make it faster, that's what I'm going to do. I'm just going to cut the 3 pins flush with the board, like so. And then I'm just going to solder my wires to these pads when I put some fresh solder on top. So, we're going to twist the wires and then tin them. The excitement ensues. Grab the soldering iron. Yeah, it's off camera a little bit, sorry. I'm just adding a little bit of solder to the copper, which this wire I believe is technically copper coated aluminum. Yep. So now that everything's nice and silver, now I'm going to add some fresh solder to these 3 spots so I can get a good bond. Clean the tip. There we go. There. And just remember, whichever way you solder the wires, you want to duplicate it on the other end. And what I'm going to do is I'm going to trim these down a hair, make them a little shorter off the circuit board so they're less likely to touch each other. I'm basically going to do blue in the middle and then the reds on the outside. If you have a set of helping hands, those might come in handy. so your wires stay where they need to be and you don't burn yourself. So I have my 3 wires on. And just to make them a little neater, you can use electrical tape, super glue, hot glue, normal tape, just clear tape or masking, zip ties if you want. I'm just going to put a little piece of heat shrink in the middle to keep the bundle together. And then I'm also going to put a small piece over this thing, the IR reader. So when they're soldered on, if something was to happen, moisture, leakage, that it's protected from arcing the 3 pins. It's not going to be 100% protection, but something is better than nothing. I'm also going to tin this. The problem with tinning components is you don't want to overheat the component and damage it. So try not to apply heat for a long period of time. Hopefully just long enough to get a bead on what you're working on. So it's 2. Let's see if I can get this middle one. There. It's not a lot of solder. Hopefully it's enough to let it bind. And to match this end, on the left, the blue and the red are the ones that are connected together. So that would be the left and the middle on this this part. Oh, I need a little bit more solder. If you're having a problem with the solder sticking, you can also use flux. The last time I remoted one of these, I didn't have to, but we're going to see if this holds. If it doesn't, then I'll flux it. Nope, there we go. Wish I knew where my helping hands disappeared to. That is 2. And 3. So there's all 3. We can give it a test just to make sure it works. Probably a good idea. So plug it in. The lights. Here's the IR. Here's the remote. Yeah, still works. Off, on. Yep. That ensures that the solder joints are a good connection and they're not cracked or separated. So Now what I'm going to do is slide the heat shrink up over the bottom of this. Yeah, remember I was just saying? I just broke the solder connection. There we go. Also, it had a point. If you have a point on your solder, your heat shrink can get a puncture in it or tear. You try and slide it over. There we go. Heat gun. A little toasty there. There we go. So. All right. Now the reason your switch has 3 pins is it's a two-way switch. You can see there's a pin, and a pin. So when it's, according to the mask, when it's over to this side, it's on, this side is off. What I was doing is just taking this center wire and either running power down the right side or left side. So if I flip this to on, that means it's running off of the battery. What I'm going to do is make it so if I flip it this way, it's going to run off the AC adapter. And then I'll just use this to turn it off. So we're going to solder onto that additional pin. I'm just going to use the blue wire that was left over from the piece I stripped. So I'm going to twist it and tin it. And then the principles of doing this is the same thing I've done when I do like Limax houses that are 120 volt light bulbs, and I don't like running anything on incandescent bulbs when it comes to those, since I have so many and I don't want to overdraw a circuit. I will do stuff like this, except I won't have a switch like this, but the principle is the same. I have done a split switch like this on a stereo that I did, where it runs off of a couple of volts AC adapter, and then when you lose power, if you want to listen to the radio still, you flip the switch the other direction and it turns on the battery pack, which is 4Ds. How we're going to make this a dual power is normally on a switch, the power comes in the center and goes out one of the sides. If it's got 2 posts, one of the sides. If it's a single post, it's just the other side. To make this a dual power to where it works with both battery and AC adapter without frying your battery pack, the power actually comes in on the sides and runs out the center. So it's basically using the switch backwards. It's not really backwards, it's a switch. It doesn't really care. But it's counterintuitive to what most people think. So this wire here in the center is the power from the battery. This blue wire will be the power from the AC adapter. So these 2 wires, because this other wire is the power that powers this, I'm going to reverse them. You might have to use fresh solder. You might have to flux it, just depends. The solder I'm using is still good, there's still flux in it. And I'm going to have to put some on that one. So, it's a very simple switch of switching the wires around. To show you how it works, got the AC adapter already plugged in. So I'm going to plug in guess I got to hook the ground up. The ground for the AC adapter, I'm just going to solder to the back of this, the 9-volt plate. Reason is it's already the grounding circuit for this. It's all hooked together. So, need to complete the circuit, and by doing so, this way both will work. They're both going to share a common negative, or return, or ground. It's technically negative. And then they're going to have a split positive. I added solder to the solder that was already on here because when it's, as you can see, it look, lights up. Go. Because the AC adapter is plugged in. So let's turn off the power. And you can see that the lights, let's get some more lights off here. There we go. A little bit better. Oh, look, it's off. Now it's back on because of the AC adapter. So, if I take my battery, plug it in, if I switch, it stays on. And then the only way to turn it off would be using the remote, like so. So it's very simple to make things dual power without using a diode setup, just by reversing the polarity, or what you believe would be the polarity of the switch. Most switches don't have a problem with it. Not a big issue. I've done it on several different things. I have a stereo I've done it on, so that way if I lose power, I can flip it to the battery backup, because the stereo was never designed to run on anything other than batteries. So I reversed it to where it's a battery backup stereo. So let's plug this back in, since when I was moving it around it knocked itself out. And we're going to put the mask on, and I'm just going to have this hanging down by the power switch. I don't feel like feeding it through his helmet on the top, nor do I want to notch this out personally. To me it wouldn't look right. So, first I'm going to pull out the excess black wire. You don't have to run as much wire. I like to have extra wire in case something breaks or has to be replaced and I have to cut the end off. I'm not short. When I work on custom cars, I do the same thing. That way I don't have to deal with bad wiring, or wiring that fails down the road, and then being short on wire and having to run a new section. I prefer not to connect wires to wires if I can avoid it. Sometimes it's not as good as a solid wire connection. So, just going to feed this over to near the switch. The bulb side, the side that protrudes out, is the side that reads the actual sensor. So when you stick it in, make sure that you rotate it so it faces forward. If it doesn't face forward, it's going to be slightly harder for it to read the signals from the controller. Rotate that, and where did I put all the screws? One. Two. That one didn't line up. Now you may be noticing that on the controller part where the battery goes, the battery isn't going to fit very well with that AC adapter plug. I'm probably going to go out and try and find one that has a 90-degree head versus a straight barrel. That way it actually fits better. Because the battery isn't going to fit back in here as it sits. But at the moment, that's all I could find was the straight one. I would run a Limax controller, but they're less than 5 volts. And at below 5 volts, this thing is dim. Flush, and see if I can get this screw hole to line up. There we go. There it is. Power light's off. Switch it back to AC adapter. I believe you can see the face lighting up, but just to be safe, I'm going to go kill the other lights. And there's the controller. Off, on, white, blue, green, red. See, now I don't have to have it right up against the side of his mask. Now it's down here. And it's got to point basically at his chin. Press a button, and done. Back to white. So if you're working on a project that you want to have dual power or the ability for dual power, that's basically how you do it. This is just for the principles. I have done centerpieces from like Limax as an example, the ones that come with the battery packs, or even the ones from Department 56 that come with these battery packs. The light. Some people might be familiar with them. They're 2C batteries in here, and it puts out 3 volts, where you can plug into it here or use that plug. Don't plug them together though, then you can create a short. When I use one of these, I will just find an AC adapter that already has this size, which is a 2.5 millimeter jack. So that way it's dual power, because not all of them come with it. But I've also set it up to where I've changed this switch to one that has 3 pins, and when this is plugged in, it's AC. When this is plugged off, when it's switched over, it's the DC battery is the secondary. So again, it's just a concept for anybody who wants to take something that runs on a battery and give it the option of a wall socket, so that way they can have dual power. So I'll hook the battery back up. Okay. Once I get that 90, it'll fit flush. And I'll switch the switch. You should see it flash. And then flash back. So that's battery. That's AC adapter. So just to show you this battery, I'm going to hook the battery. And the lights went out. So hopefully this helps you with some of the things you might want to do. Gives you some ideas. That way you can make things dual power that run on LED that are low power. Thanks for watching the update to the mask. Have a good one. One last addendum. My mask slipped out of my hand and it came unplugged, so I opened it back up and hot glued that 4-pin connector together so it doesn't come apart. But forgot to show you how I was going to close this. The door right in the middle between the two fingers, I cut a little notch in the door for the wire to hang down. So that way it hangs relatively flush against the wall. So that way it doesn't like cause the door to bow or anything. So I just use a set of angle or flush cutters. So, but yeah, apparently that little 4-pin connector that has the IR attached to it, probably put a dab of hot glue on it if you do something like this so it doesn't come apart, because it's not held together with anything other than tension, and there's not a lot of it on there. And when I was screwing this on and it slid out of my hand, the lights went out, and I'm like, oh, open it up, it came undone. So I hot glued that 4-pin, and I put a dab of glue on the wires that were right here by the jaw that were all around that standoff for the screw. I glued it to the bottom so it doesn't keep lifting, so it won't interfere with any of these lights here. It wasn't to begin with, but you know, Murphy. So there it is. Now technically it's all complete until I can find a plug that has a 90-degree barrel that I can fit in there with the battery.